So that one has been alarmed. And if the temperature goes above 60 degrees Fahrenheit, I get an SMS on my mobile. And this actually happened while I was on my way to visit the Argonne National Laboratory for 3 days. As I was walking into the building, my mobile went off. It was the wine cellar calling. And it said that the temperature had just broken through the 60-degree Fahrenheit barrier. And sadly, my wife was away for 2 weeks, and no one was home to turn on the cooling system again. So every 5 minutes for the next 3 days, I kept getting this note saying your wine is warming up. I finally got home, and it was 70 degrees in the wine cellar, which isn't not a disaster. But I did call my friends at Archrock, and they said, "Do you make remote actuators?" And they said yes. So the project now is to put a remote actuator in with strong authentication so that the 15-year-old next door doesn't reprogram the house while I'm away. And I noted that because I could see light levels changing in each room, that I might be able to tell if someone had gone into the wine cellar while I was away. But of course they didn't know what they had done. So the next idea is to put an RFID chip on each bottle and be able to do an instantaneous inventory of all the bottles in the wine cellar in case anything had left the wine cellar without my permission. Of course, one of my engineering friends pointed out that there was a flaw in the design because you could go into the wine cellar and drink the wine and leave the bottle. So this is why we have smart grid, priority action panels and engineers to evaluate designs. So we're going to have to put sensors in the cork. And as long as we do that, we might as well do something to sense the esters in the wine to see whether it's ready to drink. And before you open the bottle, you interrogate the cork. And if this is the bottle that got up to 95 degrees or something, that's one you give to a friend who doesn't know the difference. So this is a small sample of the kinds of things that we would, I think, regularly expect in residences and certainly in industry and in buildings around the United States and elsewhere to gather more data about environmental conditions and how well we are meeting them. So I want to make one point which I made earlier today in the governing board meeting and which got a certain degree of resonance, and that is that we should not be confining our thinking as we think about the architecture to just electrical power and the consumption of electrical power or the control of demand for electrical power. Please think about this as a system which is accumulating information about our resource consumption, including oil and gas and water and other important resources. Because in the end, if our intent is to optimize the way in which we use these resources, we may actually have a multi-commodity optimization to worry about. We may need to know more about how we're consuming resources and when, not just electricity, but some of these others. The implication of that is that the architecture and the means of expression of our consumption and use, or pricing and all these other things, should be generalizable so that we can deal with some of these other commodities. I'm not saying we should go solve the multi-commodity problem now. I'm certainly not saying we should figure out what all those things should be now. We have a big enough, hard enough problem with the smart grid, electrical grid, but I think we should be cognizant of the utility of thinking more broadly about what it is that we are doing. I've been told that the Japanese have something called the smart community, and they are speaking of multi-commodity measurement metrics and the like. So they are already in some ways ahead of my thinking anyway. So I put that on the table not as not to throw a grenade into the conversation, but to say that generalizability, extensibility is really important in the design, and we should keep that in mind. So the smart grid, in some sense, is only the beginning of thinking about how we account for our consumption of resources. So the key ingredient in all of this, in my view, is information. Because in a sense, it's not possible to manage our use of power, to control the distribution of power, or other commodities, except for having the right information to know what we should do. When am I using it? How much am I using it? What are the prices? And when are those prices changing? All of that is just information. And so figuring out how to present or represent that information, how to share and distribute the information, how to assure that parties who can usefully benefit from that information and are able to get it, is all a part of the kinds of architecture that we should be thinking about designing. So there are some things that I believe would be desirable in the architecture. I won't even call them principles because that sounds too deep, but just simply features that we ought to keep in mind. This is absolutely not a complete list at all, and I'm sure that you'll come up with many more ideas than I have. But one thing is adaptability in the design. I don't think that any single communication method will be sufficient to link the various devices that we want to monitor and control together. So we can't just pick one communication medium in order to make this work. Things get moved around the house. Things get moved from house to house, or from office to office, or moved around the plant floor. So we may discover that any particular choice of medium only works for a subset of the places where we want things to be. So we are, I think, compelled to think about how to design this system so that the communications can go over a variety of different physical layers, or MAC-PHY layers, whether it's a wired Ethernet or a power line or a serial channel or various wireless options. And I'm sure I deliberately have not listed all because I don't know what they all are. And some of them are being invented literally as we speak. But we should be very conscious of the need to allow devices to move from one communication regime to another at need, depending on what works for purposes of managing and monitoring these things. One possibility is to design into the appliances that we're trying to track a way of easily replacing the communication capability with something else if it's needed. We could get into enormous arguments, and probably some of you already have, about whether that's possible and how to do it and what impact does it have on the cost of things. Flexibility often comes at a price, but the one thing which I believe is inescapable from my point of view is that we won't be able to pick one or two, one wired and one wireless means, and assume that that will work for everybody for all situations. And so we need to think more carefully about how to be adaptable. The other thing that's important is that devices, many of them, are going to last for a long time. We don't replace a lot of the equipment that consumes electricity very often. Water tubes don't get replaced very often. They usually get replaced after there's a catastrophe and something leaks in the basement. So the same is true for a great many of the things that consume these resources, an oil burner or a gas burner. So they last for a long time, and one of the questions is how well can they be adapted to changing circumstances, given that they are not replaced with great frequency. So again, this, for me anyway, reinforces the need for adaptable architectures. Plug and play, which is a sort of an overused term, but I think it's very important, especially if we're considering consumers who are not necessarily experts at all in communication networking or our network architecture or debugging or anything else. So if this is going to work at all, it's going to have to work in a way which is largely transparent to most of the users. You'd also like it not to be the case, I think, that in order to install something which is part of the smart grid program, that you have to send a person out to do configuration and debugging and the like. Well, the implications of that are actually fairly dramatic, because it means that these systems have to have self-organizing properties. The devices have to find each other. The monitoring systems have to find the devices. We have to distinguish the devices they're supposed